Hello dear students, all of you welcome to Vidyan classes. Today we will discuss on elementary operation or transformation of a matrix. Elementary operation or it is called transformation of a matrix. There are 6 rules. There are 6 rules on elementary operations or transformations with respect to rows and columns of a matrix. There exist 3 rules with respect to row and 3 rules with respect to column. A contains 2 rules, B contains 2 rules and C contains 2 rules. What is A? The interchange of any 2 rows or 2 columns. The interchange of any 2 rows or 2 columns. Rule 1. That is the interchange ith row will be jth row. Rule 2. ith column will be jth column. ith column replaced by ith row replaced by jth row or jth row replaced by ith row. It is rule 1. According to rule 2, ith column can be replaced by jth column and jth column is replaced by ith column. That means interchange of any 2 rows, ith row and jth row are interchanged. ith column and jth column are interchanged. For example, it is example 1. Let capital A is a matrix having elements 1, 2, 3, 0, 4, 5, 2, 3, 1. Applying first row and third row. Applying row 1 is replaced by row 3 and row 3 is replaced by row 1. That means the interchange of row 1 and row 3. We get a matrix capital B interchanging row 1 and row 3. First row will be third row 2, 3, 1. There is no change of second row. Row 3 will be row 1. 1, 2, 3. The arrow mark is replaced, is read as replaced by. The arrow mark is read as replaced by. Row 1 is replaced by row 3. Row 3 is replaced by row 1. Example 2. Similarly, we can apply on column. Let capital C be a matrix having elements 1, root 2, root 3, 2, 0, 5. Applying column 1 is replaced by column 2 and column 2 is replaced by column 1. We get another matrix, that is D. Column 1 is replaced by column 2. Column of 2 contains root 2 0. So it is root 2 0. Column 2 is replaced by column 1. Column 1 contains 1 and 2. There is no change of column 3. Clear? Column 1 is replaced by column 2. Column 2 is replaced by column 1. According to rule 2, there are 6 rules. A contains 2 rules. Clear? Okay. Next, B. The multiplication of the elements of any row or column by a non-zero real number. Symbolically, it is written as the multiplication of the elements of any row or column by a non-zero number. That means real number. Let k not equal to 0. Rule 3. The multiplication of the elements of any row or column by a non-zero real number. Ith column is replaced by k times of ith column. The multiplication of the elements of any row or column. Rule 4. Ith row is replaced by k times of ith row, where k belongs to R, that means any real number, k not equal to 0. Example 3. Let capital X is a matrix having elements 0 2 3 1 2 5 minus 1 0 7. Applying row 2 replaced by 2 times of row 2. The multiplication of the elements of any row or column by a non-zero real. That means ith row can be replaced by k times of ith row, and ith column is replaced by k times of kth column. Row 2 is replaced by 2 times of row 2. We get another matrix. Suppose it is Y. There is no change of row 1 and row 3. Row 2 is replaced by 2 times of row 2. 2, 4 and 10. Minus 1, 0, 7. Row 2 is replaced by 2 times of row 2. Example 4. Let L be the matrix having elements root 2, root 3, 5, 1, 0, minus 1. Applying column 3 is replaced by 3 times of column 3. Let M be the matrix. L is this matrix. Applying C3 is replaced by 3 times of C3. We will get another matrix. Suppose it is M. Which contains root 2 1, root 3 0. C3 is replaced by 3 times of C3. 3 into 5 that is 15. 3 into minus 1 is equal to minus 3. Clear? Multiplication of the elements of any row or column by a non-zero number mathematically or symbolically it is written as, this is rule 3, it is rule 4. Column 3 is replaced by 3 times. Column 3 contains 5 and minus 1. 3 times of 5 that is 15 and 3 times of minus 1 that is minus 3. There is no change of column 1 and column 2. Clear? Next, see the addition of the elements of any row or column. The corresponding elements of any other row or column multiplied by any non-zero number. Non-zero number means any real number not equal to 0. Symbolically it is written as rule 5, ith row is replaced by ith row plus k times of ith row plus k times of jth row. Rule 6, ith column is replaced by ith column plus k times of jth column. The given statement mathematically or symbolically it is written as ith row can be replaced by ith row plus k times of jth row. Ith column is replaced by ith column plus k times of jth column, where k belongs to R, that means set of real numbers, and k not equal to 0. Example 5, let P be a matrix having elements 2, 3, minus 3, 1, 5, 0, 2, 1, minus 2. Applying row 2 is replaced by row 2 plus 2 times of row 3. We get another matrix, suppose Q. Row 2 is replaced by row 2 plus 2 times of row 3. There is no change of row 1 and row 3. Row 1 contains 2, 3, minus 3. Row 2 is replaced by row 2 plus 2 times of row 3. 1 plus 2 times of 2 that is equal to 5. 5 into 2 times of 1 that is equal to 7. 0 plus 2 times of minus 2 that is equal to minus 4. Row 2 is replaced by row 2 plus 2 times of row 3. No change of row 3, that means 2, 1, minus 2. Clear? According to rule 5. Again let example 5, 6, let R be the matrix having elements 1, 2, 3, 0, minus 1, 2. Applying column 1 is replaced by column 1 plus minus 2 times of column 3. Column 1 is replaced by column 1 plus 2 times of column 3, where k is minus 2. We get another matrix, that is S, which is same as column 1 is replaced by column 1 plus minus 2 times of column 3. 1 minus 2 into 3, that is equal to 6, minus 6 plus 1, that is minus 5. 0 minus 2 times of 2, that is equal to minus 4. Clear? Column 1 contains 1, 0. 1 plus 2 times of minus 2 times of 3, that is equal to minus 6 plus 1, that is equal to minus 5. 0 plus 2 times of 2, that minus 2 times of 2, that is equal to 0 plus minus 4, that is equal to minus 4. There is no change of column 2 and column 3. Column 1 is replaced by column 1 plus 2 times of column 3, which gives 2. There is no change of column 2, 3 and 2. No change of column 2 and column 3. Column 1 is replaced by, that means column 1 will be column 1 plus 2 times of minus 2 times of column 3. 1 plus 3 into minus 2, which gives minus 5. 0 plus 2 into minus 2, which gives minus 4. No change of column 2 and column 3. There are 6 rules in elementary operation. A contains 2 rules, B contains 2 rules, and C contains 2 rules. There are 6 rules in elementary operation. Elementary operation, which is also called transformation of a matrix. Clear? Okay. Write down. Write down. Using elementary operation or transformation, find the unit matrix of the following matrices. There are 6 rules in elementary operation or transformation. There exist 3 row operation and 3 column operation. We will find the unit matrix using row operation or column operation. Suppose the first bit is solved by the column operation. Applying C1 replaced by C3 and C3 is replaced by C1. We get the given matrix will be 1, 0, 0. There is no change of column 2, 0, 0, 1. Column 3 is replaced by column 1, that is 0, 1 and 0. Again, applying C, it is C2, it is C3. Column 2 is replaced by column 3 and column 3 is replaced by column 2 is replaced by column 3 and column 3 is replaced by column 2. We get the matrix having elements 1 0 0 0 1 0 and 0 0 1, which is the unit matrix of order 3. It is a unit matrix of order 3, which is denoted by I or I3. I3 means unit matrix of order 3. Clear? The first bit is solved by using column operation. Second bit, we will find the unit matrix, either column matrix or row matrix. Applying C2 replaced by C2 minus 2 times of C1. That means using the column operation, C2 is replaced by C2 minus C1. We get the matrix having elements 1 0 0. 2 minus 2 times of C1, that is equal to 0. 1 minus 2 times of C1, that is equal to 0. 0 minus 2 times of 0, that is equal to 0. The third column remains silent, which is 0 0 3. Again, applying C3 is replaced by 1 by 3 C3. We get the matrix having elements 1 0 0. It is 1, sorry. 1 minus, that is 1. 0, 1 and 0. C3 is replaced by 1 by 3 C3. It is 0, 0 and 1. Which is a unit matrix of order 3 or which is written as I. Here, the second bit is solved by using column operation. Suppose the third bit will prove the unit matrix using row operation. Applying row 1 is replaced by 1 by 2 row 1 and row 2 is replaced by 1 by 2 row 2. We get the matrix having element 1 by 3. Row 1 is replaced by 1 by 3 row 1, which gives 2 1. It is 1, it is 1. Again apply row 2, row 1 is replaced by row 1 is replaced by row 1 minus row 2. We get the matrix having elements, it is 1, 0, 1 and 1. Again applying row 2 replaced by row 2 minus row 1. We get the matrix having elements, row 2 is replaced by row 2 minus row 1. 1 minus 1, that is equal to 0. 1 minus 1, that is equal to 0. 1 minus 0, that is equal to 1, which is a unit matrix of order 2, or written as I. Clear? Using row operation, we get the unit matrix. Applying row 1 replaced by 1 by 3 row 1, which gives 2 and 1. Applying row 2 replaced by 1 by 2 row 2, we get 1 and 1. Applying row 1 replaced by row 1 minus row 2, we get the matrix 2 minus 1, that is equal to 1, 1 minus 1, that is equal to 0, 1, 1. Again applying row 2 replaced by row 2 minus row 1. The first row remains silent. The second row will be 1 minus 1, that is equal to 0, and 1 minus 0, that is equal to 1, which is a unit matrix of order 2. Clear? Okay, write down.